Hello, you're welcome. All right, so now the topic is set theory. Okay, so we're gonna be looking at different theory of set. But before then, let's define set. All right. Now, what is a set? Now, a set is defined as a collection. All right, collection of well-defined objects. Collection of well-defined objects. I am very sure that you must have actually heard of mathematical set before, right? And I'm sure you must have bought one. So when you open a mathematical set, the things you see inside a mathematical set is mathematical too, all right? So a set must be a collection of a well-defined object. And that object, all right, the object of the set is also what is known as the element of the set. And it must be defined, all right? Because if it is not defined, you might end up having a disjointed set. For example, if I say a set of numbers, it will be wrong for me to actually include an alphabet inside the set of numbers. I hope that is well understood. Okay, so now this is how we actually represent a set. Okay, let's see if I say a set A, all right, then the element of A should be enclosed in a braces, not bracket. All right, so element of a set is always enclosed in braces. All right, I hope that is well understood. So now in this tutorial, we're going to be looking at the basic concept or terms, all right, that is used in describing a set. And I believe you're with me. All right. Now the very basic concept is the concept of membership of a set, or the element of a set, right? Element of set. Okay, having said that, excuse me. Okay, so now I haven't actually said that the element of a set is enclosed in a braces. Okay, let's say I have set A to be a set of numbers 1, 2, 3, 4, dot dot dots. Okay, A has this element. Why? All right. Now, if I want to actually describe or to say that 2 is an element of A, that's a way I'll write it. All right. So this tutorial will help you to know how to write symbols, all right, that illustrate a set. So I can simply say that if I want to say 2, all right, it's an element of A, I will go like this. 2 is an element of A. That's how I will do that. But let's say A being an alphabet is not an element of small letter A is not an element of A. All right, I'll just do like this. Small letter A is not an element of A. So this is how we use this is a symbol we use in representing the element of a set. So I hope that is well understood, right? Okay. Now for us to actually list the element of a set, all right, there are two ways of listing an element of a set. One of them is the way I've actually given you, okay, this method I've given you, okay, where you list out the element, excuse me, you list out the elements, okay, explicitly, okay, possibly end it where you want to end it, or you use dot dot to show that it continues in that sequence. This one way of actually doing that. Or another way of actually listing out the element of a set is using what is known as set builder. Set builder notation. I will show you how that works. Now, set builder is a very simpler way of describing the element of a set without listing it out. So with the set builder, someone will know exactly from the description, the person can actually write the element. Okay, let me give you a typical example of a set builder. All right, so let's look at, we have set B. Then in braces, set B is actually has elements. Okay, the element of B is X. Then I use this such or this. Okay, but let me use this X element. B has element X such that X, okay, is integer, so that S is an integer. Then and another description is that X is greater than 0. So as you can see, this particular statement inside the braces didn't list out the set, but it gives me the information, okay, that will enable me to list out the set. So invariably now, if I want to list out the set of B, all right, so I'm looking at B being X and it's an integer, all right, and that integer is greater than 0. That means I have to start from 1. Now the set didn't build, that didn't tell me where to stop, so that means it's going to be to infinity, right? But I can just write and use dot dot to show that it continues, right? So that means B gonna be 1, 2, 3, 4. Then you cannot do comma dot 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 dot. So the person seeing this know that, okay, yeah, it continues like that, probably to infinity, since there is no range, okay, for B. I hope that is well understood. Next term that we're going to look at is called the equality of a set. Equality of sets. So the question is, when are sets said to be equal? Since they are made up of elements, all right? Now, I will simply say, let me use two sets. Let's say set A and B. Okay, if I say set, excuse me, if I say set A is equal to B, what does that imply? For this, I write it, all right, equal to. It simply means that all the elements of A should be the same as the element of B. As simple as that. So one is not greater than the other, right? They have the same element, the same number of elements and the same type of element. So if A is let's say 1, 2, 3, okay, 4, then of course B should still be the same thing. 1, 2, 3, 4. Now it may not necessarily be in the same order, all right, but the elements must be the same and equal. That is the equality of a set. That's one term. Another term we want to look at is what is known as singleton set. As the name implies, a singleton set is simply a set that contains, all right, single element, just one element, okay, or let me use one. Okay, so this set contains one element. It's a singleton set. All right, so for example, if A is equal to 2, so A is a singleton set. I hope we are good. Okay, let's go through the terms. Okay, the next thing we're going to look at is empty set. Now, empty set is a set that doesn't have any element. Are you okay? And it's either you call it empty set or you call it a null set. It doesn't have any element inside of it. Okay, so if I say that A is an empty set, I use this symbol. This one way of representing empty set. Okay, this symbol for empty. Or I can say A is gonna be equal to an empty braces. All right, this is another way for expressing empty. So if I actually ask you, list out the set of elements, okay, or the set of numbers that are used as alphabet, well, will I say that is empty? Okay, now which simply means that if something is empty, you should know very well that once the description of that particular set is being given, okay, there's no element that will be found in that set. All right, so let me not bring a contradictory or a confusing example, right? So let's go on with the terms. Okay, so we're still gonna look at another term, all right? Excuse me. This is called, we're gonna look at a finite set. All right. Now, a set is said to be finite if the element is actually countable. All right, as the name imply. So in a finite set, I don't use dot dot dot. It's not to infinity. All right. For example, if A is a finite set, then I can simply say that A is, let's say A is just A, B, comma C, comma D. All right, and it stops there. But if a set is infinite, all right, if a set is an infinite set, okay, you know that such set continues to infinity. So for me to represent what happens, I can just use dot 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 to show that it continues. It's not countable. I hope that is well understood. All right, let's look at the next term. All right, the next term is a subset. As the name implies, sub of a set. Now, if I have two sets, let me use two sets as an example. All right, in situation where the element of one set is derived from another set, they are said to be subset. Okay, so if we have set A and B, okay, being two sets, now if every element of A, all right, is also the element of B, that means A element of A is probably derived from B, gotten from B. Okay, I can say that A is a subset of B, and this is how I write it. All right, this is a symbol of subset, and please take note of the symbols, because in exams, if you are being asked to list out, okay, the element of set, you will not be given in words, you'll be given by symbol. So this shows that A is a subset of B. All right, A is a subset of B. So let's look at some example. If I have A to be equal to, let's say, 2, all right, comma 3, comma 4, comma 5. And B, all right, is have the same 1, 2, all right, comma 3, comma 4, comma 5. So you see all the elements, okay? So if I say A is a subset of B, of course, A is a subset and is equal to, this is subset, sub and equal to. It can be sub but not equal to. Okay, A is derived from B and all the elements of A is also equal to the element of B. So A is a subset of B. So in such a case, all right, equality has actually been satisfied. Are you good? Equality have been satisfied. But there are different ways of actually, there's a subset known as proper subset, all right? In proper subset, equality of the two sets is not satisfied. In a case of proper subset, all right, I will only do this. A is a subset of B. Because why? Because if I do this, simply means that B is greater than A. Then okay, so A is only part of the element of B. For example, let's say a situation where you have A being, okay, let me still use this example, 2, 3, 4, 5. All right, then B have the same but more. 2, 3, 4, 5, then 6, probably 7. All right, so I can simply say that, okay, B is A is a subset of B derived from, but it's not equal to B. All right, so I hope that is well understood. So now we are going to still look at more, but this time around let's look at the operation of a set. I think this is where most question comes out in exams. Okay, operation. Anytime you hear of operation of any particular subject matter, a mathematical operation is simply excuse me, talks about, okay, simplifications, something like addition, subtraction, and so in sets. So whenever you are being asked to solve question on set, mostly it comes in terms of the operation, okay, and those operation in set is what what we are going to be looking at. Number one operation we're going to look at is operation that happens when we find the union of sets. All right. Number two operation is an operation that involves looking for the intersection of sets. Operation also we look for difference. Okay. Difference, especially of two sets. All right. We also have an operation that involves complement of a set from its universal set. Complement of a set. All right. After looking at that, if there are more, I will bring it up. Right. We'll look at Venn diagram. But before then, let's look at the union. Right. Let's start with union. So let's look at union of just two sets, right? But you can also extend the definition to more than two sets. So the union of two sets is simply the element that is found in both sets. Are you okay? In one set or both sets. when you list out all the elements, for example, and of course, let's say we have a being equal to 1 comma 2 comma 5 comma 6, then b being equal to 2 comma 7 comma 8. All right, so if you're being asked to find the union between these two sets, we use the symbol A union B. All right, so it's simply the set of elements that list out all the elements, but without repeating any elements. You can't, we don't repeat a union, right? So for me to avoid repeating, I'll list all the elements from A to B, probably in ascending order. Okay, so I'll start with the lowest, which is 1. 1 is found in A. I have 2, all right, which of course is found in both. I'll list it out. Okay, there's no 3, of course. There is 5. There is 7, right? Okay, there is 5. There is 6. Oh, there is 7, and there is 8. Done. So please take note of that union. All right, intersection. All right, so intersection of two sets. Now, this intersection of two sets is commonly, or intersection of sets is commonly defined as the element that is common to the, all right, to the both sets. The list of the element that's common, or the boundary. Okay, you know, at a place where there's a common element or common relationship, you have a boundary, right? So now let me use what I have here in this example, A and B. You discover very well that the point where A and B intersect is at 2. A there is 2 and B there is 2. All right, so this is how we represent intersection. Please take note of the symbol. Okay, so A intersection B, which we use N, that connects A and B to represent, of course, union is U, right? So just 2. I hope that is well understood. The next is difference. Okay, difference of two sets. All right, as the name implies. Okay, so it's just like subtracting one set from the other, and mostly we do difference, okay, between two sets if one set is a subset of the other. Okay, that's it. It will only work. It can only subtract something from, okay, something that is actually greater than it or equal to it. For example, if I have 20, I can say that I will subtract 20, all right, to have 0, or subtract something lower than. In terms of set, though in mathematics we can do this to have negative sign, but in sets we don't. So it's mostly subtract a subset, all right, from each proper subset. Excuse me. Okay, so let's say I have A. Let me just to be equal to 1 comma 2 comma 3 comma 4. Then I have B to be equal to 2 comma 4. All right, let me just stop here. So now look at how we represent difference. So B, I'm going to subtract B from A. All right, so I'll do A difference B. So I'm only removing the element of B from A. So I'll write what is left. So that means I'm removing 2 from A, and I'm going to remove 4 from A. So what I have left is going to be equal to 1, right? Comma 3. As simple as that. I hope we are flowing. Okay, so those are the basic concepts. If you understand this basic concept, okay, by the time you get to the complex questions, you know how to tackle them. Okay, then the complement of the sets. Before I define this, I'm now going to introduce what is known as universal sets. All right, it will actually make sense for you to know about universal sets before we talk about complement. Okay, as the name imply, okay, I'm using you to represent it. Universal set, okay, is actually a set that contains all the elements under that definition. Okay, so under, remember, a set is actually a collection of well-defined objects. So there's a definition for the set. Okay, so when you define a set and you have a set that contains all elements, under that definition, such a set is called universal set. All right, so let's say my consideration is a universal set, which I will use a set builder, okay, being a set of X and S such that excuse me, 1 is less or equal to X and X is less or equal to 10. So discover that from this range, this universal set carries everything under this definition, and that's going to be, the range is going to be from 1 to 10, all right? So if I want to list my universal set, I have 1, 2, everything will be inclusive, 3, 4, 5, 6, 7, 8, 9, and of course, 10. Okay. Are we good? Yes, we are. So now we simply mean that this is the universal set. Now to show that the universal set carries everything, that might be a subset under the universal set. Okay, I can now define another set. Okay, set A. Let me use set builder. Okay, set A is actually has element X, such that X is still within the same range. But S is even numbers. Let me make it simple, right? Even numbers, okay? So you're looking at a subset A, but it's an even number between the universal set 1 to 10, all right? So if I'm listing out A, so A is actually a subset of the universal set, which captures the even number from 1 to 10, right? So you know what are even numbers, right? Numbers that can be divided by 2 without remainder. So 2, 4, 6, 8, then 10. So now this leads me to what is known as complement. Now we majorly use complement is something as difference, all right? Complement is something as actually difference. They are similar, but in complement we are considering, okay, the difference between that set and its universal set, not between two sets, okay, two sets in which one is a subset, all right? So in a situation like this, now complement of a set is simply the element, or complement of A rather, here I want to use, is the element that I can see in the universal set where this A is derived from, but it's not found in this set. All right. So simply A complement. If I want to make you understand it better, of course we use A complement or A prime. It's also, if you see A prime, okay, A raised power C or A raised power prime, are you okay? It's something as doing the universal set, then of course difference A. So I'm subtracting A from the universal set. What I have becomes the complement. Now, since A are all even numbers, all right, so the complement of A from the universal set is, will be the odd numbers. So what I'm listing out is just the odd numbers from 1 to 10. That's going to be 1, 3, 5, 7, and 9. So I hope that actually makes sense. Okay. All right. So we are going to look at a series of examples just in the next video before we now talk about Venn diagram. All right. See you in the next video. Thank you very much.